For this example, we want to identify the open interval on which the function is increasing or decreasing. We're given the function h of x equals cosine of 3x over 2, and we're restricting our conversation here to just this interval from 0 to 2 pi, since the cosine function and the sine function are sort of like wave functions. So they're going to have many changes in increasing and decreasing, infinite changes in increasing and decreasing. So limiting us to only 0 to 2 pi is very helpful. So when we're looking for intervals of increasing and decreasing, we want to use the derivative. Whenever the derivative is positive or greater than 0, the original function is increasing. So let's use h prime instead of f. And when the derivative is negative or less than 0, the original function is decreasing. So we're going to start by calculating the derivative of this h of x equals cosine of 3x over 2. So to calculate the derivative, I'm going to use the chain rule. And with the chain rule, we calculate the derivative on our outside function first. So derivative of cosine is negative sine. We're going to leave the inside the same, but we need to chain by multiplying by the derivative of the inside part. The derivative of 3x over 2 is 3 over 2. We have negative sine of 3x over 2 times 3 over 2. So we'll write this as negative 3 over 2 sine of 3x over 2. So once we've calculated the derivative, we need to find the critical numbers. Critical numbers are where the derivative is equal to 0. The derivative being positive or greater than 0, excuse me, my pen's acting up here. When the derivative is greater than 0, it's increasing. When it's less than 0, it's decreasing. When it's equal to 0, we're looking for that boundary point. So the critical numbers act as that boundary point. Okay, so we'll set this derivative equal to 0. Negative 3 over 2 sine of 3x over 2 equals 0. We can multiply both sides by negative 2/3. So this cancels out the coefficient. 0 times negative 2/3 is 0. We have sine of 3x over 2 equals 0. Now to solve this trig equation, we're going to use the unit circle. I have a copy of the unit circle right here. Let's get it on the whiteboard. And sine on the unit circle is the y coordinate. So we're looking for when, because we have sine, the y coordinate is equal to 0. So we can see we have an ordered pair 1, 0, negative 1, 0. So our angles of 0, 2 pi, and pi are all angles where sine of that angle is equal to 0. Now we need to be a little bit careful here because remember we said that we're limiting x to be from 0 to 2 pi. But our angle, the angle inside of sine is not just an x, it's 3x over 2. So let's take a look at that for a second. If x is limited between 0 and 2 pi, where is our angle limited? So our angle is 3x over 2, so I'm going to multiply this inequality by 3 over 2 on each part. And we have 3 over 2 times 0 is 0. In the middle, we have 3 over 2x. And then here we have 3 over 2 times 2 pi. The 2's cancel, and we get 3 pi. So although x is limited between 0 and 2 pi, this angle is limited between 0 and 3 pi. So we don't have an equal to on this 0, so we're going to leave this out. But an angle of pi and an angle of 2 pi lie within 0 to 3 pi. So we're going to use both of those. So that angle, 3x over 2, could be pi, or 3x over 2 could be 2 pi. We'll multiply both sides by 2 over 3. And we get that x is equal to 2/3 pi, or x is equal to 4/3 pi. So that gives us our critical numbers of 2/3 pi and 4/3 pi. So I'm going to use these critical numbers to set up my number line. So these are going to be our boundary points, and we'll separate these intervals of increasing and decreasing. So on my number line, remember that we're restricting ourselves from 0 to 2 pi. So we're starting at 0, going all the way to 2 pi, and I wrote open circles on there. We're excluding everything outside of those numbers. We have our critical numbers of 2 pi over 3 and 4 pi over 3. And we need to test each one of these intervals into the derivative to see if the function is increasing or decreasing. So I need to pick a test point from 0 to 2 pi over 3. So 2 pi over 3 is right here. So I'm going to pick my test point as some angle along this part of the unit circle. So how about a nice one like pi over 2? Pick pi over 2, substitute it into the derivative. We're doing h prime. H prime at pi over 2 would be negative 3 over 2 sine 3 over 2 times pi over 2. That's negative 3 over 2 sine of 3 pi over 4. And sine of 3 pi over 4 is right here, and that's going to be the y coordinate. That's a positive square root of 2 over 2. We have negative 3 over 2 times square root of 2 over 2. That gives me a negative 3 square root of 2 over 4. So we have a negative in that interval. We're decreasing on that interval. Okay, so now I want to pick a test point from 2 pi over 3 to 4 pi over 3. Okay, so 4 pi over 3 is right here. So I need to pick something along this section here. Pi is a nice value to choose, so I'll choose pi. I need to calculate the derivative at pi, h prime at pi. That's negative 3 over 2 sine of 3 pi over 2. So 3 pi over 2 is right here. And the y-coordinate, sine is the y-coordinate, is -1. So we have -3 over 2 times -1. That's a positive 3 over 2. So it's positive, and this interval is increasing in that interval. We have one more interval to test. We need to test from 4 pi over 3 to 2 pi. This is 2 pi, so we need to pick a test point somewhere along this section here. Excuse me. So to pick a test point somewhere in that interval, how about 3 pi over 2? We're going to do h prime at 3 pi over 2. -3 over 2 times sine of 3 over 2 times 3 pi over 2. This is -3 over 2 sine of 9 pi over 2. And 9 pi over 2 is not on the unit circle here. So let's see if we can think of what's equivalent to 9 pi over 2. So to do that, I'm going to subtract 2 pi. And I would need a common denominator, so I'll multiply by 2 over 2. So I have 9 pi over 2 minus 8 pi over 2. That's pi over 2. So that 9 pi over 2 is equivalent to pi over 2. So pi over 2 is 90 degrees. The y-coordinate is a positive 1. We get -3 over 2 times positive 1. We get a negative in that interval. So it's decreasing in that interval. So we're going to answer that this function is increasing on the interval where the derivative is positive. That's 2 pi over 3 to 4 pi over 3. And decreasing from 0 to 2 pi over 3. So this is where the derivative is negative. And also 4 pi over 3 to 2 pi. For this example, we want to calculate the derivative of g of x equals arccosine of x over 8. So let's look at the derivative rule for arccosine. Derivative of arccosine of u is u prime, negative u prime over square root 1 minus u squared. So we want to follow this derivative pattern in order to calculate that derivative. So first we want to identify the inside function. We've got x over 8. So we're going to calculate that derivative of the inside function. So the derivative of x over 8. So that's our u. That's going to give us a negative derivative of x over 8. That's 1/8. One other thing I should mention here is that we have this 2 in the front. That's a constant multiple, so we need to carry that over as well. We need to multiply by 2. And in the denominator, we're going to do the square root of 1 minus u squared. So that's x over 8 squared. So we have 2 in the numerator, 2 times -1/8. So that's -2/8 over square root of 1 minus, let's apply the square in the denominator, that's x squared over 64. And we can simplify this by multiplying by 8 over 8. So this is going to cancel out the 8 in the numerator. We have this 8 right here, a denominator of 8 in the numerator, so it'll cancel that out. And when we bring this 8 inside of the radical, it's going to become a 64, because square root of 64 is 8, and it'll cancel out the 64 that we have in this denominator. So we'll have negative 2 over square root of 1 minus x squared over 64. And I'm going to change this 8 to square root of 64. So times square root of 64. Square root of 64 is the same thing as 8. And now that it's a square root, I can bring it inside of this square root. When you multiply square roots, square root of a times square root of b is equal to square root of a times b, as long as a and b are both positive. So this will give me negative 2 over square root 64 minus x squared. Because when we multiply the square root of 64 times x squared over 64, the 64's cancel, and we also have to distribute it to this 1. Square root of 64 times square root of 1 gives us that square root of 64 there. Thank you for checking out my videos. Have a great day.